Well, we are already so late, so what I'm going to request is that we have two speakers here already with us, so they can share their experience because they have been leading big departments or colleges in education in agricultural engineering for a long time. And so they can tell their ideas how we handle the education for future, so youth can be attracted to work in the agriculture sector in general and agricultural engineering in particular. So may I request first Professor M.K. Jha. He is the head of Agricultural and Food Engineering Department of Indian Institute of Technology at Kharagpur. I think that should be sufficient introduction, Madan. Okay, so please come and share your views how we handle the education in future for youth. Yeah.
Good afternoon to all of you. Respected Professor G. Singh sir, respected Sam sir, and other dignitaries, and respected also dear Dr. Khodke. So, although it is lunchtime, but we are still not waiting for the lunch. So that is so because this session has to be also concluded. So regarding this, I was given only 10 minutes time, but I may take little bit more, and that's there will be no problem because no other speakers are there. So. Okay. So, okay, I will take only 10 minutes time. Okay, no problem. So, my journey from in agriculture engineering was also a little bit tough, and I will start from my experience as a student, and then when I went abroad, then my my thinking for agricultural engineering and other became very broad, and also I learned many new things. And after that, I got a job at IIT Kharagpur. I joined an assistant professor in absentia, and since then I'm there. 24 years I have spent at IIT Kharagpur, and I have seen that the modern generation youths are more thinking for job. They are also coming with the IIT Kharagpur main purpose. I have interacted with many years with the students that what is your purpose to come for MTech? Then they are telling job. Because why you came to IIT? Why not other institute? I came to IIT to get a good job. So this is the response. And for that, they want to do some degree from IIT. And then whatever batches I am teaching, and over the years, I have seen that most of the students have the tendency to get degree and IIT logo rather than learning. And as a result, many fundamentals of agricultural engineering are very much lacking at MTech level. So this is the first thing we have to do for future. To give more this kind of fundamental type of knowledge, and also they should give that you should be a job, not always job taker, rather job seeker, or you can give the job also. So that kind of situation and condition should be also prevail in India, and that is very much there. And with our present governance by Mr. Modi, so he has given the startup, and a startup is a one platform through which one can jump into the job taker, job giver, and then also young generations can have better life, and also through a startup journey, one can get some innovative work, innovations. This is why in IIT Kharagpur, we have the education system, we have the startup systems also. We have separately Agri-Business Incubation Foundation, and that is located in a Section 8 company, as a Section 8 company in our department only. And I am also one of the directors of the ABIF, and I am interacting with very promising young engineers, young scientists, and they are doing excellent innovative work. And and through ABI platform, they are also getting promoted and motivated. And that way, so I also request the agricultural engineering vice chancellors, all universities vice chancellors, to create such kind of course so that some startups of innovative center, center of entrepreneurship or center of innovative knowledge or innovative technology, such that people with more practical oriented work, they should go to that center and get training. Regarding AI/ML, people are just thinking that every problem solution is AI/ML. I can tell you that in my field, groundwater hydrology, I am among the few in the world who use the AI/ML technique first in India. At least in the world also, I am few among the world. I use AI, that ANN, that time it was called ANN. Today also it is a sister or grand sister of AI/ML is nothing but the ANN, artificial intelligence. And I am continuing with that. And my suggestion to the youngsters will be, AI/ML is not a panacea for all maladies. It is one of the modeling tool, which can help us and which can also facilitate the automation thing. Artificial intelligence, all these things have come because of AI/ML only. But artificial intelligence word is artificial. It cannot replace the human intelligence. So artificial intelligence system, if it has not been developed by an expert, then it will not be serve a real purpose. It will be only as a model or software. And one example, Chat GPT is also many message you might have found on the social media, and the Chat GPT misuse and use. So what I want to say that none of the technology should be used blindly. Rather, you try to find out the what is the need, your need, and for that really you need AI/ML, or you need only the our traditional technique only, which is cost effective also, and with the help of, then that is enough, that you decide. If it is not enough, we should also add some AI/ML part also. Then you add it. Think how to add it, how to amalgam the traditional knowledge, our traditional knowledge, as well as the modern knowledge. This is the main need of the hour, to train our students, young minds, so that they can be a better citizen tomorrow. And and lastly, I would like to say that also at BTech level, we developed ICR with the ICR one project. We developed e-courses first for all the BTech courses running in the ICR sponsored agricultural universities. But I'm asking every year, asking my students, how many you have gone through the this e-courses? Most of the students say, no, sir, it is not taught. No, I don't know about this course. Only one or two students say, some group, some year, yes, sir, I have read your irrigation drainage or something, or some other courses in other discipline. So this is a taker is not there. Nobody is there in the agriculture university to see that why you are not using e-courses. It has been done by the reviewing by the two persons, and also the topic was not given to anybody who is not teaching that topic, who has some more experience. Based upon that lecture or lesson has been prepared. It is a very quality material, and that must be minimum taught at BTech level, which is not happening. I am not satisfied at all. I was thinking that sometime I will talk to DDG sir, that please instruct all agriculture universities that e-course should be used as a course material, rather than simply giving the name of the book and tell the student, you will read that chapter, that chapter, and from that I will ask in the examination. This is a normal trend. If this trend must has been broken, if you want to go into future in a better way and you want to find that our country should, because we can't escape from agriculture like developed countries. Agriculture is the backbone of India. We cannot. So this is why the agriculture sector must grow up, and it is growing up, and but it should grow up in a more sustainable manner so that it should not break in between. Uh, and and with this these words, I will stop my short lecture, and thank you very much.
Thank you, Professor Madan Jha. Those who are really interested in studying at IIT Kharagpur, so you know the person whom to contact. He is a very easily accessible person. Okay. Now, I'd like to invite Dr. R.P. Kingsley Ambrose. He is a professor of agricultural and biological engineering at Purdue University in the United States. He is going to tell us education in US and comparison with system in India. You want to be on that side? Oh, no, you can be here. Okay, okay. You can add to your introduction if you like to. You can introduce, you can give extra introduction if you like to do, okay? Yeah.
Thank you, Dr. Gajendra Singh. So, good afternoon, all. Hopefully, I think I have 10 minutes to talk, right? So, and I will not take much time. So, I'm going to talk about transforming. The title is very attractive, but I may not be talking everything in that title what we have. But once again, I wanted to thank Dr. Jha, Dr. Mishra, and even Dr. Vishwanathan and all for inviting me to come here, to attend this ISA meeting. Okay. The next one. Okay, just to introduce, Dr. Gajendra Singh asked me to introduce. So he introduced me. So I'm a professor of ag and biological engineering at Purdue. And before going there, I was at CIFET for about 6 years. So many of my colleagues I can see here. So from there, I became faculty after my PhD there, and then continuing to stay there at Purdue. So my outline, I'm not going to go much in detail, but I'm going to compare the plan of study or plans of study of both my alma mater, like TNAU and Purdue. So how different the classes, not exactly the classes, but how different the credits are, and what kind of things that we do, in the US, maybe, again, not to follow or anything, but, just for comparison purposes. Okay. And again, I'll end with, what opportunities lies ahead, for all ag engineers, overall in India and also in the US. Okay. Next. So again, I'm not going to reiterate, all those verbatim here, but, you all know that the role of ag engineers have changed a lot, right? So mostly in 1960s, we will talk about, contributing to mechanization, contributing to kind of supporting green revolution, etc. But recently, what our role is, how our role has changed. Dr. Baroda, ex-DDG, ex-Director General, talked about, conservation agriculture or sustainable agriculture, etc. So now in the 2020s, mostly we look for our contribution. I've listed some of these aspects again. Most of them Dr. Baroda and Dr. Jha covered in their speeches. how can we contribute to maintain the soil health? What will be our role in kind of maintaining the sustainable agriculture, in the world? Precision agriculture, it has developed a lot. So what are we contributing and how are we contributing? And then again, what curriculum changes we have to make, so that we still contribute to all these changes, that we see in the world. Okay. So I'll just give an introduction about the programs mostly in the US. So again, I'm comparing from Purdue here. So there are different programs that we have in the same, agricultural or agricultural and biological engineering department. So ag engineering is one part of it. We have ENRE, or environmental and natural resources, biological engineering, etc. Again, most of these divisions came from the need, for the industry, or need by the industry. What specific roles an ag engineer should play, either in a food industry, even in pharmaceutical industry, or, a regular general ag engineering, university. But again, comparing with what, we have in TNAU, or what current role, and just quickly, you know, ag engineering is not ag engineering in all the universities in the US. They go by different names. I've listed some of these, names here. But biosystems engineering, biological engineering is very common, common modification of ag engineering program. Next. So okay, comparing with what we have, again, I'm comparing with what we have in TNAU. So there are like 3 different programs. It's good to see, some diversifications of, or branching out from, traditional ag engineering program. So again, ag engineering, food technology, energy and environmental engineering too. So again, how do we cater to the industry needs? How do we have to develop or design, curriculum and criterias for, whatever sustained industry needs for, good inputs. Okay. Next. I'll just quickly go through the number of credits. So in the India, so in Indian programs, we study a lot. So we can compare, in the US, most of the programs, at least at Purdue, the total credits is 128. So if you complete 128 credits, you get a degree. Again, there are other requirements. I will talk about that in a minute. But for our programs in India, it's mostly 180 to 185 credits. So are we studying a lot? Again, are we studying everything that's again needed by the industry or to work? I'm not sure. Again, it depends, right? So the other programs that we have at Purdue is like summer internships. Most of them are paid by the industry, and also co-op or cooperative programs. That means the students stay in the industry for about 6 months. They skip a semester and then come back and do the classes. So they completely work in the industry for 6 months, and then they get industry experience and also real world experience while studying. Again, I split the number of credits, again, comparing Purdue and India here at TNAU. So you can see basic engineering almost very similar. Sciences, little less, sciences includes economics too. So a little higher than what we study in India. But again, the soil and water aspects are not much. We, at Purdue, at least only 2 classes the students take, on soil and water. Farm machinery and power is more, focused for the ag engineering program. So again, to about 15 credits, and then, other capstone, senior design projects, etc. So total it comes to about 128, credits. And in general, they are supposed to complete in 4 years, but in most of the students take about 4.5 to 5 years to, complete the degree. Many of them go for summer internships or co-op programs, so they delay their graduation in 4 years. But we try to send them out in 4.5 years, but many of them still, do industry internships and delay their, graduation. So, I'm saying, most of the students, or not most, almost all the students will have an individual advisor. So they advise the students on which classes they can register that help them with their curriculum, overall development, etc. Okay, so advising is very important component of their whatever undergrad study. Right? One quick thing again, programming is kind of changing. Earlier, programming is not needed, but nowadays, most of the engineering programs need some programming skills for the students. Okay. And other than the total credits, there are some college and university requirements. So there are some set of classes that the students have to take if they wanted a degree from that college and also from the university. So they will have to go through these requirements like science requirement, humanities, etc. So they have to take some classes like anthropology or history, etc. That adds to the adds to their credits. Okay. I'll talk about engineering technical selective here. So how we, again, just this table, again, lots of number there, but I'm, if you're reading, read from the right to left, from 2006 to 2024. So how things have changed. So, but you might see in basic engineering and sciences, there might be some changes, and those came from the reduction of total number of credits needed to graduate. So now we just need 128 credits. So that came from that reduction. And you could see earlier programming used to be optional. Now it's like kind of compulsory that all the students has to complete, if they graduate, if they have to graduate. Okay, so how do we usually change the curriculum or program? So there are like kind of three process or three steps that we go through. The major thing is alumni interaction. So we bring in lots of alumni to the department and talk to them. And alumni mostly working in industry. So we talk to them and ask them like, what are the skills that the students need? What are they missing when they graduate? So based on their feedback, we change the classes, class modify, syllabus or curriculum, etc. So that, when they're ready and when they graduate, they are ready to go for job or find a job. Okay. So that's first one, alumni. Then we do have, again, almost all engineering programs in the US has to go through this ABET accreditation. ABET accreditation, they do not, comment on the individual classes per se, but they do comment on, okay, what your students are missing or what your curriculum is missing, or what you're doing good and what you have to improve in your, program. So that's the role of ABET or the accreditation program. And then we do have another review, that's a department review. That's mostly done by the colleagues from other universities. So usually like senior faculty, they come and do review. And they don't comment on the classes, but mostly they comment on the programs. Okay, this program, maybe you're not doing well, maybe you have to change the focus of the program, or you add another program so that you get more number of students, etc. Okay. So all these three processes are very important in, changing the courses, changing the curriculum, changing or modifying the curriculum, etc. One of the difference that I see from what we do in India and the US is most of the students do undergraduate research. So at least like 2 to 3 credits of research that they do. So they join some faculty or faculty groups, and they will be assigned some independent research. So they are trained on conducting or doing research independently. So one of the advantages is that motivates them. Okay, I'm almost done. Okay. So again, that motivates them to do research or for study into go and get admission to grad school, etc. So that's again one of the important parts. And I would love to quickly. Hopefully, the PowerPoint is coming back up. We do the ASAB almost. I believe you all know about ASABE. That's the American Society of Ag and Biological Engineers. They do also play a larger role by kind of bringing in together undergraduate students for different competitions. Next. Next. Okay, so different competitions, again, no national competitions are, important part of, again, ASAB annual meetings. Here, I'm not speaking well enough. Okay. So again, go to the next slide, please. Oh, okay. Hello. Hello. Okay. So again, yeah, as I said, it's not working yet. So, ASAB's involvement is also, can you hear me? Okay.
Youthin is fine.
Okay, so again, yeah, lots of competitions for undergraduate students that, students compete. So that, brings involvement for the students into the, ag engineering profession. So at least top three teams will be invited and compete during the annual meeting. Okay. Again, go to the next one. So again, challenges, there are many challenges. Again, Dr. Jai and Dr. Baroda and all, talked a lot about, the challenges competing with other engineering programs. Usually creating an identity for ag engineering is always a challenge, but, how do we create an identity through, studying focused classes or focused program that only we can, do, or only we can do the job than a mechanical engineer or a civil engineer. Okay. I'll go to the next one. I'll complete one more slide. Next. Again, I believe the next one is the job opportunity. So again, I talked about, a lot of, these things, sustainable ag, soil health, those are the, growing, industry or job opportunities that an ag engineer can contribute a lot. Again, I'm not reading everything, but, I'll be happy to discuss, after the presentation. So go to the next one. Next slide. Okay, so some of thing, I'll just quickly go through it. Programming skills, in different classes at Purdue undergrad program, the students programming like, learn programming like Python, MATLAB, etc. that they apply and use it in lots of other programs. Data science has been increasing a lot, are applying, data science into ag. Yeah, hands-on skill and experience is much needed. Mostly that's the part where ag engineers play a larger role. Agricultural engineers comes with good hands-on experience rather than other general engineers. So that's, that makes us stand out. Couple of things again, yeah, alumni participation is very important. If we can bring in more alumni to contribute to the program, that will definitely help our programs too. I think that's my last slide. So, thank you all again. Quick, introduction.
Thank you very much. Thank you. Thank you very much, Dr. Kingsley.
Youthin is fine.
Well, next I'd like to invite Dr. P.K. Srivastava. Dr. P.K. Srivastava, well, he has a lot of experience of very different places, but I'm going to challenge him to finish in 5 minutes. Anything new? Anything? Because you're no.
Okay.
Yeah. Thank you.
Thank you very much, Professor, for giving me an challenge of finishing 5 minutes. I will try that. So, I will start with two words said in the morning. Agricultural engineering is the engineering of agriculture. One word. Second, I am adding decisions decide destiny. So decision of joining agricultural engineering might have decided and will decide destiny of many others. Uh, well, okay. Aspirations are varying from time to time of youth. Observations are that Indian talent is very high, but they are average. One observation. Second observation, our youth are no more interested in we say skilled jobs. They want to have a peace of mind, so-called peace of mind, but ease of doing job. Computer, laptop, all these things without movements. This is, you make a consider plus or minus. There are many strengths in India. Roaring IT industry, startup system, all right. Agriculture engineering has ever been accepting the challenges. I will not repeat mechanization, industrialization, drudgery, all these words are related. So again, there is a challenge how agriculture engineering will be in 2047 when there is an inspirational concept of Viksit Bharat. So I was concentrating on that, trying to discuss with you, but time will not permit. But yes, there are some points. We are supposed to be the fifth largest economy and probably fourth now and expecting to be third within next few years. But target is 8% GDP growth rate, 30 million, 30 trillion plus US dollar plus economy by 2047. Challenge is very high. We have shown very good progress in all sectors. In spite of revolutions in agriculture, why agriculture is blamed to perform poor? This is the question. So, if engineering of agriculture is engineering, so the challenge is before agriculture engineering. I was trying to list, there are 30 plus new skills, starting from AI, robotics, sensors, 3D printing, and so on. So everybody cannot be trained on every skill. So we have to identify which skill with which specialization, how to skill, cross skill, reskill, all these things, which type of education should be provided which focuses more on the skill rather than theoretical training, teaching. That's, we have our course curriculum is very rich, but probably lacking on the skill part. So keeping in mind that the future agriculture, and we are talking agriculture in 2047, our profession in India started in 1940s with Professor Masonwa, and probably before that also. So, lot of new challenges are there, and our educational sector has to reform, perform, and transform. So, this is with all these words, I say many plus points in our culture, but this challenge, as the challenge was given to me, I pass on the challenge to all youngsters. Come up with the modern skills and perform for the agriculture in 2047. Thank you very much, Professor. I hope you will give me passing marks.
Okay, the next speaker is Dr. Kumar Vimal. He is Vice President Marketing of International Tractors Limited in New Delhi. And he is going to talk about agriculture engineering education, industry readiness. So you will have 7 minutes.
Sure, sir.
Okay.
Good afternoon, ladies and gentlemen. Honor to be here. And I represent industry, so I would relate to, what is our view of employability. And I start with a statement saying that the industry always says that we are not getting the right stuff when we are going to the colleges. The colleges believe that industry is not supporting the agri-engineers. And in turn, the agri-engineers say that what's the point of studying? We are not getting jobs. So probably all the three stakeholders are at the crossroad and they are unable to really achieve what they are wanting to. Yeah, can we go quickly? Yeah, next please. So, as we heard here, we have been following a traditional way of a lot of academic knowledge, but the skilling part and the real field job is not really there. And that's where, we see that there is a gap in way of how we teach. Next. And the companies also, now the patience to really groom people is not visible in the corporate. So they're also looking at people who are at least half ready, if not full. And that's where probably, the gap between what we are getting and what we need is there. And so there is a lot of relevance to the real job training during the studies, which is what we heard maybe a 6 months summer course, and a lot of other solutions to this. So what we would like to say is the companies will have to enter the colleges and the colleges will have to enter the companies if we have to really make a big difference to the employability of the students. And these are the three pillars that we can talk of. One is industry integration between colleges and the industry, student development, and of course, third, the alumni network. If we are believing in these three pillars, probably the employability and the benefits to all the stakeholders will be huge. So today what we see is that the industry requirements and what is being taught, there is a gap. And a lot of modern requirements are happening in the industry, like what we heard, AI, robotics, ergonomics, alternate fuels, digitalization, and all that. So probably this needs to get integrated in some way or the other in the academics, continuously upgrading the syllabus with the industry interactions. And we can offer a lot of electives now, instead of hard coding it, we can have those credits, whatever, 180, 120 is a bigger game, but probably offering credits so that the students from third year start choosing what they are interested in and also get better skilled when they get out of the colleges. So this is what I believe is an interesting area. And then the students, while they are getting their studies done, the bookish knowledge, they are unable to understand as to what's happening outside, what's happening in the industry, what is happening to the consumer. And so probably, uh, there should be continuous engagement of the students with the industry, not just a job fair where you see, the industries come and interview people. It has to start much before. Probably from the third year, the students should get exposed with the industry very, very regularly. They should have mentors in the industry whom they can reach to understand what's a career that they can take and what is it that they can really learn. I believe that this would be most critical to the success, one, for the industries and also for the students and colleges. And so have real world projects, have internships, summer trainings, a lot of lectures from the industry to the students. Online, offline is fine, but have continuous engagement. And the faculty and the campuses will have to really push students to this because they really don't understand that it's important till they get out of the fourth year and they feel that they are jobless. Yeah. And then the student will have to take their own responsibility of grooming themselves, getting online certifications, getting into softer skills, having studying a lot outside the science to understand what's happening outside and groom themselves up into better people and better employable people. Yeah. And alumni, as we heard, are a very powerful linkage between colleges, the students, and the industry. So, getting engaged with the alumni, what we saw here, we saw Mahindras, we saw Escorts, we saw Sonalika, all other companies, Myco, whatever, everybody has an alumni. And if the colleges can, first of all, link up with those alumni very, very seriously, not just to felicitate them, but to really engage with them to understand what's required, how the alumni can help. But it cannot be just to giving jobs. It is too late if we reach out to alumni to say that, please, sir, give jobs to our people. Because the corporates, the alumni, they have their own pressures of performance. They have business profits to be delivered. But if the engagement is much prior, if understanding is much prior, if the readiness is much prior, I am sure that the people will be much more employable. Industries will be much more happy because they will be earning money. They would be making profit because every guy who is productive is making sense to the company. So this is all what I would like to say and communicate, sir. Hopefully 7 minutes. Thank you so much, friends.
मतलब ये है कि अब बोलना सबको बंद कर देना चाहिए, बोलना बहुत हो गया. आई थिंक वी हैव 4 presentations. We leave it to you to digest it, make your own conclusions. I have been in education all my life. I started with agricultural systems, looking at the agriculture sector as a whole, and call it agricultural systems engineering. And it included all sectors of agriculture, whether it's animal husbandry, whether it's fisheries, because aquacultural engineering was also part of it, and food and so on. So I'm going to stop it right there because we are already so late and the industry session is already so much delayed and industry people will leave even without making their presentation if we don't hold the session on time. Thank you very much, and I close the session.
All are requested to have a lunch, and at 3:15 we will again gather here for the industry session. Thank you very much.